How should we measure the performance of the economy? Now, this is a very prominent topic in our politics, and it's generally something that we discuss all the time in conversation. We often talk about whether one country is more powerful than another by discussing metrics about the economies of those countries. So what is the correct way to measure this? Well, in this video, I want to tell you about an intellectual adventure that I went on, thinking about this back in 2017. I want to explain the answer that I came up with, but which I think is a nice answer with some nice properties. And I want to tell you a little bit about the adventure that I had when I tried to communicate this answer to economists and other people that are interested in economics. So there are two very popular and very well-known measures that we talk about all the time. The first is the gross domestic product. Okay, this is the definition of the GDP as given by the Bureau of Economic Research. It's a measure of all economic activity by measuring the value of the final goods and services produced in a period of time without double counting. Okay, so that's one measure. And a second measure that we talk about all the time is the unemployment rate. Okay, and politicians will often discuss these measures. They will say that their policies are better for improving these numbers. But are these numbers really worth measuring? Are they good numbers to measure? Does it really make sense to measure how much is produced and how many people are unemployed? There are a few signs that these are not good things to measure. For example, here's a headline about China. So in China, every year, the government sets targets for what GDP will be for the next year. And once they set these targets, they will meet them. Because the Chinese government has enough control over the entire economy that they can control production. They can simply produce more skyscrapers. They can just choose to do this and so change this number. But is that really meaningful economic activity? Is that really a sign? If that number is higher, is that really a sign that the Chinese economy is doing better? There's clear evidence that there's not, because in fact they don't choose to set this number to be as high as possible. They've been hurt by doing that. In the past, they've set this number at 7% growth every year, and recently they've decided to not bring it down to 5% because they've been getting into trouble. Okay. So that's a sign that something is wrong with measuring this number. It's not really a measure of the performance of the underlying thing. It's really a number that can be picked by the government. Now, you might think that we don't have the same kind of problems in the US, but I think we do, because even though the US is supposedly a market-based economy, the government has the ability to control the supply of money, for example. They could just simply increase the amount of money that's out there, and that will change measurements of the GDP. Okay. And also, we build objects like this. So here's a beautiful object. This is the F-35 fighter jet. Each one costs $100 million. Now, if you build 500 of these or 5,000 of these, it will significantly change the underlying numbers about the economy. But is that really a good thing? Are we really getting a stronger economy by doing that? There's a problem with measuring these numbers as is. And in fact, sometimes these problems show up in our political debates. So here's an example of a debate that's related to military spending that happened a few election cycles ago between Mitt Romney and Barack Obama.
And that's this.
About 30 seconds.
Our Navy is older, our Navy is smaller now than any time since 1917. The Navy said they needed 313 ships to carry out their mission. We're now down to 285. We're headed down to the low 200s if we go through with sequestration. That's unacceptable to me. And I will not cut our military budget by $1 trillion which is the combination of the budget cuts that the president has, as well as the sequestration cuts. That, in my view, is making our future less certain and less secure.
Bob, I just need to comment on this. I think Governor Romney maybe hasn't spent enough time looking at how our military works. You mentioned the Navy, for example, and that we have fewer ships than we did in 1916. Well, Governor, we also have fewer horses and bayonets. And so the question is not a game of battleship where we're counting ships. It's what are our capabilities?
So you see, in that conversation, the debate is about, first of all, they have a disagreement about what kinds of objects are valuable for the economy to produce. That's the first thing to observe. So there's no objective way to decide what's valuable to produce. The second thing is, it's clear that these individuals, when they get into office, have immense power over the numbers. They're talking about trillions of dollars moving this way or that. Okay, so the measurements of GDP is not really a measurement. It's not really an observation of a system from the outside. It's something that can be controlled from the outside. And that makes it not a good way to evaluate the performance of the system. Another problem with all of these measurements is technology. You know, if a technology shows up that reduces the cost of every car by 1/3, let's say, that's a huge win for everyone. You know, we've had a technological breakthrough, but it will actually reduce the numbers in these measurements. Okay. So something is weird when the number goes the wrong way and there's a technological breakthrough. So those are the reasons I don't like those numbers. So now let me discuss an alternative. And you know, there's no one right answer to the question of how to measure the performance of the economy. But what I think I came up with is a different method that is very natural. It makes a lot of sense, and it does not have many of the problems associated with these standard measures. So to explain the concepts that I came up with, let's start with just a basic question. What is the function of the economy? We're trying to measure the performance of the economy, so we should first agree on the function that the economy is satisfying. Well, there are many answers to this question. There's no single right answer. One answer, the first answer, which is related to the previous measures, would be that the goal of the economy is to produce useful goods and services, and so we should measure how well it's doing that. And as I mentioned, the problem with that is that we can't quite agree on what's useful, and also the production itself is something that can be just gamed by large power, by governments, for example. A second answer, it's the answer that I'm going to go with to explain the concept that I want to put forward here, is that the function of the economy is to match economic agents with resources. So all of the entities in the economy, there are people, companies, governments, all of the various entities that build up the economy. Think of them as agents. Each of them brings to the table some resources. I might bring my labor to the table. A farmer might bring some wheat to the table. And the economy then does a reallocation of these resources. It shuttles those resources around, moving them from one agent to another in a way that's supposed to benefit everyone. Okay, this is very loosely speaking another function of the economy. And there might be many other functions of the economy, but the concepts that I'm coming up with are geared towards trying to measure how well the economy is carrying out this allocation. The allocation of resources to agents. All right, so in order to measure this, I defined what I call the trade network. So what is a trade network? So a trade network is a graph or a network. So you take a fixed period of time, let's say January 2024 to December 2025. Okay. And in that interval of time, you measure all of the transactions that occur between all of the agents in the economy. So all of the people, the companies, the governments, they're all transacting with each other. And every time there's a transaction, there's some exchange of goods and services between two of the agents that generates an edge of the trade network. Okay. So the edges between the agents here correspond to transactions, and the transactions are weighted by the monetary value of the exchange between the various agents. Okay. You can also measure, for each transaction, what is the underlying good or service that's being exchanged, and use that to color the edges, which is what I've done in this picture. But actually, for most of this talk, let's forget about what kind of thing is exchanged, and let's focus on thinking of money being exchanged. Okay. So that is the data that I want to base the measurements that I want to make on. Okay. So think of all the transactions that are happening in the system. That's the data. And the first thing I discovered is that this data is actually available. Okay. In many senses, it is possible to actually gather this data and get it on a very large scale. So you can get a massive data set with these kinds of values. I'll talk about how I discovered that towards the end of the talk. Okay, so what can we do with this object? Now we've gathered this data, we have this. What does it tell us? Well, I think this object tells us a lot about the performance of the economy. And that's because the network, you see, encodes much more information than just the total volume of transactions. The GDP is sort of a measure of the total volume of transactions. What is the total amount of money exchanged? That's one way to think about the GDP, to a coarse approximation. But you can have two networks where the total volume exchange is more or less the same, but they're very different from each other. For example, the network A and the network B in this picture, the total number of edges is the same in the network. But B has a feature that you have like two components that are very disconnected from each other. There are very few transactions going across. And A does not have that feature. Okay, so there's some sense in which A and B are different from each other. And I want to suggest that there is meaning to this. That the way this network is connected communicates information about the health of the economy. Okay, that's the thesis that I want to put forward. So why do I believe that to be true? Let me try to illustrate the intuition for it using a story. So let's imagine for a second that we're in a very primitive river valley for a long, long time ago, okay? 2000 BC. There's a fast-flowing river in this valley, and then there are farmers scattered all over, and this is their trade network. So you observe them for 2 years and you see how they interact with each other. And there's a whole bunch of farms, a lot of people living here, and they're exchanging crops and all kinds of stuff with each other. And these are the transactions. So you'll see that most people exchange things with just people that are near them because it's hard to go a long way. It's hard to cross the river, so there are very few transactions happening across the river. Okay. This is the structure of the trade network. And you see, if I deleted the river from the picture, if I just showed you the network, then you can look at this network and you still see the river. Right? The river is still here. The river is an economically significant obstacle. It's actually preventing transactions from occurring. Okay, and that has a lot of implications. If there's, a massive, infestation on one side of this of the farmland, and all the crops get decimated on one side, then because it's so hard to cross the river, it's going to be difficult for the system to adjust to that shock. Okay, it's going to be difficult for wheat to flow across, and you can see that in the network. You can see that there's an obstacle in the network even before that shock happens. Okay, So I think there's something interesting to be gleaned just by looking at the structure of this network. Now, let's say at some point, fast forward 500 years later, and at some point, the people in this river valley, they build a road on one side. Okay, so they build a road, and now it's very easy to travel large distances on this road. That will change the underlying trade network. So in that period of time, if you measure how the transactions look, maybe they look like this. Now there are a whole bunch of links between agents that have farms that are close to this road. Okay, because it's easy to travel along the road and transact with people along this road. Okay, so again, we have an economically significant object, the road, just changing the efficiency of the system. And you can see a trace of it even if you don't actually see the object. You can see a trace of it in the transactions. The transactions encode the fact that there's this powerful thing that's helping the economy. Okay. Now let's fast forward another 500 years, and let's say now there is a marketplace. This little red region is a marketplace, and people show up in the marketplace and start selling their goods. That will again change the structure of the network, and once again, if you didn't see the market there, you could deduce that something is going on just from the transactions that you're seeing in the trade network. Now let's imagine that once this marketplace shows up, that there is a merchant who is a new kind of agent, one that isn't actually growing or producing anything, but simply buying on one side of the river. And so let's say the merchant has built a ferry and is like using this ferry to transport goods across and selling it at the market. So this person is a different kind of agent, and you can see that they are a different kind of agent by their role in the trade network, right? They would sort of be an agent, a rare agent that connects the two sides of this picture. Similarly, if there's a bridge, you'll again see the effect of the bridge in the network. So each of these things, the merchant, the market, the road, the bridge, these are very different kinds of concepts and objects, and they have different impacts on the behavior of the economy. But all of them have some effect on the transactions and the structure of the transactions, the shapes of the transaction that you see emerge. Okay, so my general belief is that just this all of this data about the transactions encodes in it features of the economy that capture the strengths and weaknesses of the economy. Okay, so that's just a high level belief. And so if you show me some network of transactions, this trade network, and it looks like this, and not knowing where this came from, the first thing I would ask is what's going on, what's going on right here? Okay, what's going on right here? That's strange. That's strange that there's a partition between two parts of the system. There must be something interesting going on here. Okay. Similarly, if you showed me a picture of a trade network and it looked like this, and I saw that there was this kind of agent, then I would ask, that's again really interesting, right? This agent must have a very special role in this economy. Okay, so simply from looking at the data about transactions, you can try to find, obstacles or features of the economy that are helping connect and support the allocation of goods and services to different agents. Okay, so that's a whole bunch of abstract, sort of vague ideas that this data has some useful signal. And so next what I try to do is try to find the math that can pick out that signal. Okay, that can actually give us a measurement that's meaningful. And there's a very natural kind of mathematics to use here, which is to use spectral graph theory. Now, in this video, I'm not going to discuss the details of spectral graph theory. You can look that up for yourself, but I'll just show you a whole bunch of pictures to explain what it allows you to do. So given the network, you can take that data and use it to make a matrix. It's called the Laplacian matrix. And then you can look at the eigenvalues and eigenvectors of that matrix, and you can look at the top eigenvalues and look at the corresponding eigenvectors, and they give you a way to map the nodes, the agents, to points in space. Okay, so it basically gives you a way to take this mess of agents that are connected to each other and gives you an algorithm that arranges that mess in space. Okay, so you are able to plot out the agents and arrange them in space just from the underlying transactions. And my thesis is that plot has very valuable information about the entire system. Okay, and let me explain why I have that intuition. So here's an example. So let's say you start with a 30 by 30 grid, okay, 30 by 30 grid of points. And you feed it into this Laplacian eigenvector algorithm. So you feed into this algorithm, it just gets this mess of pictures, which is the links between various points. It doesn't know, the algorithm doesn't know ahead of time that it's a 30 by 30 grid. But then you ask the algorithm to plot out the points, and this is the picture it will produce. It can reconstruct the fact that it's a 30 by 30 grid, okay, just from the links. So for those of you who do know what I'm doing here, this is, I took the top 3 eigenvectors of the normalized Laplacian, and that gave me this picture, okay, this embedding into 3-dimensional space. So here's another example. This is a dumbbell network, okay, and it just looks like a mess, but you can feed in this data into the algorithm and it will decode this structure, which shows the structure of the dumbbell network. Okay. And the cool thing about this method, the looking at the Laplacian and the eigenvectors of the Laplacian, is that it picks up large-scale features of the underlying network and it ignores small local aberrations. So for example, here are 4 different types of pictures, 4 different types of networks. And 3 of them, these 3 are roughly the same. They're roughly like sort of like just a mat. But this one is different. This one has a giant hole in it. It's more like a circle. Okay. And we can tell that visually, right? But the algorithm can tell that these are different as well. Okay, so here's an example. So here's an 80 by 80 grid. This is what the algorithm would spit out. Now here's something where each of the pieces are hexagons. Okay, so it's no longer squares in each of the grid. Each node is connected to 3 neighbors instead of 4 neighbors. Okay, so it's very different locally. But the entire thing is still, like a carpet. And the algorithm will plot it just like a carpet. Okay, and even if I put random holes in it or random noise to change it locally, it doesn't matter. The algorithm is not disrupted. It still recreates that the entire structure looks more or less like a carpet. Here's something that looks again like a grid, but instead of drawing the edges between nearby grid points, I connected every node to a random nearby node. And it still doesn't change the structure. Okay, so you still more or less have something that looks like a flat mat. Okay, so the algorithm is not fooled by such local changes. And here's an example of a grid with a hole, and now you see the algorithm produce something quite different. It detected that this hole is a significant feature of this big picture. And I just want to show you, so these are actually 3-dimensional pictures, or 3-dimensional plots. So if you look at the grid versus the object that was random connections to nearby grid points, then you see that in 3 dimensions, it's very clear that the algorithm really reconstructed the two as very close to each other. So my thesis is that this algorithm, these measurements, pick out significant high-level features of the entire system and ignore noisy local features or aberrations. Okay, which is what we want some measurement of the entire system to actually, those are features we want from a measurement of the entire system. Now, earlier I talked about the story of a river valley, right? So let's see what happens when you try to make that and feed it into this algorithm. So what happens if you take a network that looks like this and feed it into the algorithm? Well, this is what you get. So this is a grid where I reduce the number of connections right in the middle between the two sides, and the algorithm picks that out. So when you plot the points of the new network, you obtain something that really looks like it's split between two pieces that are far apart. So what happens if you have a feature that looks like a road, as we discussed before? Well, so here's what I did. I took a grid and then I picked a strip on the grid and added random connections between vertices along that strip, which are the red links in this picture. And then I fed that new network into the algorithm, and this is how it plotted it. It pulled out the agents that are participating along the road. Okay, so the algorithm is able to detect that these agents are doing something different, and something different is happening in this part of the system. And here's a picture that combines both the road and the river. Okay, so you can see the river as a feature in the middle. It's a disconnect between two parts, and then the road, and the links of the road are the red links in this picture. And here's another example. This is an example where I made a grid and added random connections between 3 areas, sort of 3 clusters of higher activity, where there are more connections within those areas on the grid. The algorithm then identifies those 3 areas and pulls them out. Okay, those 3 areas are identified as places where something special is happening. Okay, so the algorithm is able to pick out from this large system sort of high-level features that are interesting. And I think that's really powerful. So if you believe the thesis that this algorithm and these measurements are capturing something interesting, then there are many measurements that we can make. We can try to understand how well connected the entire system is. And I think that's a meaningful thing to measure. It talks about how resilient the system is to shocks, or how quickly the system is able to adapt when something changes in one part of the system, right? Generally, my intuition is that we don't want a network that is broken up into a few parts that are not well connected to each other. We want a network. A healthy economy is one where there are lots of connections, which means that there are a lot of opportunities for exchange to happen, for allocation of resources to happen. Okay, so that was all a bunch of made up data, right? I made up the network. It turns out that you can actually get your hands on actual data, okay? So for example, the Bureau of Economic Research gathers data about the transactions that are occurring between 390 industries in the United States. And this is publicly available data. So you can get a network with 390 nodes and the monetary value of transactions between them. And so I applied, the same ideas to that data. And here are the kinds of, I saw many interesting things which are along the lines of what you would expect. So for example, different industries that are similar got put very close to each other. So in this picture, you can see that 6 and 8 here, which are right next to each other, are transit and ground passenger transportation, and also state and local government passenger transit. 2, 5, and 3, they're pulp mills, paper mills, and sanitary paper and product manufacturing. 1 and 7 both have to do with aluminum. Okay, so this algorithm is able to, from this data about transactions between the various nodes, it's able to put together nodes that are performing a similar role and a related role to each other. It's able to identify that they're actually quite close to each other. Okay. And I wonder what other kinds of information is hiding in this data. That's interesting to see. So you can try to apply the things that I said to actual data, and I think that's worth doing. But another nice feature of this concept is that I think it has great explanatory power for other concepts. For example, here's a kind of mysterious thing from the perspective of economics, which I think gets a very clean explanation once you think of what's happening in terms of trade networks. And that's the idea of a futures contract. So what is a futures contract? A futures contract is a contract that says that you can sell, if you're a wheat farmer, you can sell a contract that says, give me $500 now and I will deliver wheat to you in the future, 6 months into the future. And these kinds of contracts emerged in Chicago in the 1850s. For example, with farmers selling corn. Okay, and it was a way for farmers to be able to obtain money to grow the corn before they would actually deliver the corn. They could sell it before they were delivering the corn. And in the system at that time, there was a monopoly, which is that the granaries in the cities, there were only a couple of granaries that were taking deliveries of corn. So the owners of those granaries had huge pricing power over the farmers who were selling to them. But once the farmers started using futures contracts, third parties who did not own granaries were able to buy those contracts. So people that had nothing to do with the corn industry could show up and buy the contract for delivery of corn, even though they didn't have a place to store the corn. And this allowed them, and then they could sell, those contracts to the granaries right when the granaries needed the corn. So in this way, they changed the structure of the transactions occurring in the network. And it turned out that these contracts effectively broke the monopoly of the granaries. At first, maybe it's a little confusing how it's possible that contracts that do not actually involve the transfer of corn, but that are just financial contracts, can break a monopoly. But I think once you draw it out as a trade network, it makes sense that happens. Because before you have a futures contract, the picture looks like this. The transactions that are occurring through two agents, or a few number of agents. And they have complete control over how these transactions are occurring. But after you have futures traders, then you have all kinds of other agents that are competing with each other and setting prices. You have much more of a competitive marketplace for a similar object. Not for the actual corn, but for the contract that's related to corn. And this, competition between agents bidding for these prices changes it. Now you have a healthy market for these prices. And that can break the monopoly that existed before. Okay, so I think from the network perspective, it's clear that having these other agents changes the structure of the network in a very healthy way. But if you were just to watch the flow of goods, it's far from clear that the introduction of these futures traders is actually a positive thing. So let me spend a few minutes talking about what happened when I came up with these ideas and tried to talk to economists about them. Well, I discovered a lot, both about economics and also myself. I had a very tough time communicating these ideas. First, it was very hard to communicate any of the math related to Laplacians or the spectrum or any of that stuff because people simply did not have the background to understand what I was talking about. So then I, thought that I would actually go out and try and find the data, and I did manage to find the data. I found a couple of economists, one here at the UW, who had access to exactly this data for an entire country. Okay, so there's a country that gathers data about value-added tax, and I was able to get access to huge reams of data, collected over a period of years, of all the transactions occurring between large businesses in a country. So I took this data and I applied, the Laplacian, and I got all kinds of beautiful pictures of the transactions between the businesses of this country, which I cannot show you because it's confidential. But then I didn't know what to do with that. The kind of ideas that are coming up with are very different than what is normally studied in economics. And a standard conversation I would have with economists is, I would say, hey, I have this idea. Can I tell you about it? And they would say, well, is it microeconomics or is it macroeconomics? And then I would not know how to answer that question. Okay, so I can't tell. Is it microeconomics or is it macroeconomics? And if it's not microeconomics, then I'm not interested. Or if it's not macroeconomics, then I'm not interested. That's too far away from me. That would be their answer. There's just no slot or bucket that was appropriate for these ideas to fit in. Okay. And I simply could not get actually anyone to engage on the actual ideas. The conversations are all. Sometimes I would have strange conversations, like people would ask me, "Are you planning to try and publish 2 or 3 papers before you go up for tenure using this stuff?" They were all about how this is connected to my career, or how to actually use this to make papers. And I was a little bit disappointed that I couldn't get people to actually engage on the ideas, on the actual ideas. So that's where I left it. And I would love to see someone take these ideas forward and actually analyze real data and discover something interesting about the large-scale features of economies.